Okay, so one of our standards talks about efficiency. Typically that's used in reference to simple machines, but I feel like the students really don't even grasp what efficiency is, and a lot of the data they collect when we do simple machines is not particularly reliable. So having a conversation about this pulley compared to another one based off of flawed data is not very useful. So this activity talks about efficiency, but it's not with simple machines at all. It's with these light bulbs. This is from a kit that's from LabAIDs. At the moment it's back ordered, and I'm going to show the materials that I have from this activity. They have repackaged this. I'm hoping these are the exact materials you will get. When I see it, if it's different, I will let you know how to modify it. So you'll need 2 of these little plastic trays, and these are specific to LabAIDs, or you could just, I could just make other things. So you'll need those 2 little trays, a 9-volt battery, some simple thermometers, the little metal thermometers. These are also specific to those little plastic trays. They're little foam inserts. And then you have a harness here that has an LED light and a regular light bulb light in the same harness. So what you're going to be doing is measuring water into the little well that's here. That's just 10 milliliters of water into each one. Then you're going to prepare the light bulbs. Your goal here is to find out how efficiently these bulbs work. So we know from the law of conservation of energy that the energy doesn't disappear, but it does transform. We want to see how well these bulbs, the goal of a light bulb is to produce light, but not all the energy goes into light. So you're going to poke these light bulbs through these foam inserts like that. And then these foam inserts go down in the well on top of the water. So the light bulb itself will be in the water, but the wires will not be in the water. Let's see, my wire is come loose here. I'll have to hold that one in a minute. Actually, before you put it in there, it might be helpful to go ahead and put the thermometers in there. Let me pop this one back out. So this little triangular shape is to put the thermometer through. You do need the bulb to go below the foam, but that's the only part. It just needs to have the bulb down in the water. All right. Put that in. Mix this one in. Sure if I can hold this. I need to strip the end of that wire again, so this bulb may not light. But then when you connect you're taking the initial temperature of the water, and you're going to connect your D cell to this to create a complete circuit. I'm going to try to hold it here because that wire broke. You can see both lights did turn on. At this time, students can be making comparisons. They should notice that the color of light even is different between the LED and the regular incandescent bulb. Students are going to collect data every 2 minutes for the temperature of these, and then after about 10 minutes, you're going to take these out and you're going to compare the temperatures. You will be surprised how much difference there is in temperature just in that short period of time. So the measurement is actually not of the bulb itself, but the temperature that the water is after that 10-minute period of time. And then you can have discussion on and draw as a diagram how some energy has been transformed from the chemical and electrical in your D cell first to light, but then some of that is a byproduct of heat. And provided in this kit, again, this kit is from LabAIDs, they have worksheets that if your students are capable of doing more advanced math, you might look about cost efficiency and the number of hours that these bulbs burn, because some of that information is provided. So you're comparing which is the better price and how much money or how much are you wasting on heat, and what are the ramifications for that for your air conditioning bill, for example. So it's a real cool way to show the efficiency of a light bulb and why we're supposed to be moving toward LED bulbs.